And we are going to talk about what's known in Mathland as combinatorics.
I lost the notes.
So I'm sure you've heard of the study of probability. That is included in this. So we'll be doing some probability problems. But first, you have to learn how to count. The fundamental counting principle. So here we go. Number one. How many ways can you arrange 5 books on a shelf?
Oh God.
Any?
Oh no.
You have the idea? I think it's 25. Target?
Number of outcome over favorable outcome.
Okay, you're talking about what probability is. We're talking about problem number 1 right now. We're going to get to that in a minute. But how many ways can you arrange 5 books on a shelf?
5. 25. 25.
Actually, way more than you think. 120. All right, here's the deal. Here's the deal. Pretend this is your shelf. Right here's my shelf. And here's my stack of books. How many choices do I have to pick a book for this first slot? 5. So I have 5 choices. I'm only going to pick one, but I have 5 to pick from. Now, I pick a book and I put it in a slot. How many choices do I now have for the second slot? 4. And then 3, and then 2, and then 1. And the fundamental counting principle says that if you can do the first move in 5 ways and the second move in 4 ways, then altogether you can do them in 5 times 4 ways. We multiply our options. So what we have is 5 times 4 times 3 times 2 times 1, which if you multiply all that out, it's 120. So there are 120 ways to do it. Now, what if we had 6 books? Then you do the same thing, only you start with 6.
700.
What if there had been 100 books? Then you start with 100, but can you see how awful that would be to write all that out? So there's a shorthand notation for this concept. When you start with 5 and then go down to 4, 3, 2, 1, there's a notation for that. It looks like an exclamation point. Have you seen that before? That exclamation point is the symbol for factorial. So if somebody says to me, how many ways can you arrange 5 books on a shelf? I'm going to say 5 factorial, because that means 5, 4, 3, 2, 1. So if somebody said, how many ways can you arrange 100 books on a shelf? I'm not going to write all that out. I'm just going to say 100 factorial, knowing that means 100 times 99 times 98, da 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 da. On your calculators, most of you have your calculators today. Get your calculator out, and I will show you where the factorial button is, so that you don't have to physically multiply 5 times 4 times 3 times 2 times 1. Now, can you do that?
Yeah.
Sure, but it's quicker, especially as the number gets bigger, to use your factorial button. So, if you go to your math button, just your regular math button, which is the 3rd one down in the first column, right? Regular math. And you look across the options at the top. The last option is probability. So click over to the probability. So I have probability highlighted. And what do you see on the 4th thing down? You see that symbol, right? So here's what we do. Go back, quit out of there. Go back to your main screen. Okay, hit 5, the number 5, then math, bop over to probability, bop down to the factorial, and hit equals, and it says 120. All right, so let's practice one more. If you put in 5, it shouldn't say overflow. If you put in 100, it might say overflow. We'll talk about that in a minute. Let's figure out what 10 factorial is. So 10 factorial, we type in 10.
Oh my God.
And then we press math, click over to prob, down to the exclamation point, hit enter, and what is 10 factorial? What is it?
3.628.
So it's 3 million?
No, 300,000.
300,000?
3,628,000. No, what is it?
3,628,000.
Thank you. Now, that was 10 factorial. So a minute ago, Zach said, I typed in 100 factorial. And my calculator said overflow. Why do you think that was?
Too big of a number.
If 10 factorial is already into the millions, imagine what 100 factorial is, right? So your calculator does have some limitations, which, by the way, the workaround for that is logarithms. We don't have time to get into it, but you can actually outsmart your calculator by using logarithms. But, again, factorials get really big, really fast. All right, let's try the next problem. Let's see. Seth, here are the details. All right, so the next problem says, in how many ways can 9 people stand in a line? What do you think? 9 factorial. Kids, arranging people in a line is no different than arranging books on a shelf, is it? So 9 people in a line is 9 factorial. All right, let's type it in on our calculator. According to Ruben, 9 factorial is 362,880. So there are that many ways. So Seth, baseball team. 9 guys play at a time, right? Do I have this right? 9 people play at a time in baseball? Okay. If anybody could play any position, there would be 362,880 different lineups for the coach, because you could arrange those 9 people in that many ways. How many prizes can be awarded for first, second, and third place in a race with 10 contestants? Okay, now wait a minute. Don't say 10 factorial, because you're not picking or arranging all 10 people. You are only going to give away 3 prizes. So how many choices do you have for first place? This is first place. How many choices do you have? 10. All right, so somebody has gotten the blue ribbon. Now, how many choices are there for second place? 9. And then third place. Now we're done. That's it. Don't go all the way down. Do you understand why? You're not picking a 4th and a 5th and a 6th person. You're only picking 3. So the answer would be 720. Mrs. Ford has 8 jumpers and 10 shirts. How many different outfits are possible?
You got more than 8.
What?
You know you got more than 8.
Well, actually, I do now. But let's just say I have 8 jumpers and 10 shirts. How many outfits are possible? No factorials. Because when I go to my closet to get dressed on a given day, I have to pick a jumper and I have to pick a shirt. I'm only making 2 choices. So how many do I have? How many jumpers do I have? Choices. 8. How many shirts? 10. So the answer to the problem is 80. Don't say 8 factorial. If you say 8 factorial, you are arranging all 8 jumpers. If I said to you, how many ways can I arrange my 8 jumpers in a row? You would say 8 factorial. But I don't wear 8 at a time. I only wear 1. So how many choices do I have to pick 1 jumper? 8. And then 10 for the shirts, so a total of 80. Mr. Ford has 5 sport coats, 12 shirts, and 10 pair of pants. Assuming that everything matches, how many outfits does he have? Now, he is picking 3 things, right? So he goes to his closet in the morning, he says, oh, I need a sport coat. How many choices? 5. 5 choices. Then he says, I gotta pick a shirt. How many choices? 12. And then I gotta pick a pair of pants. How many choices? 10. Multiply all those together. Always multiply. So he has 600 different outfits that he could wear.
You married?
Oh my God.
Yes. I have 4 children.
In a ring.
In the ring.
Yeah, wait.
Her name's
And I'm Mrs. Oh, it's okay. Someone not long ago thought I used to be a nun. I mean, this year, someone thought I had been a nun. And you know why?
Or
Because I'm so mean. How many ways can the whole row of the keyboard be
Pop, did you
arranged?
ask her that?
yeah.
The home row is the row that like you mainly type on, that middle row. And those letters, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 letters in that row. 9 factorial. Because you are arranging all 9. You're not just picking one, you are arranging all 9 of those. So the answer to number 6 is 9 factorial. 9 factorial. Because I'm arranging all 9 of them. Now number 7, I'm asking you to think a little bit here. You sit down, you're going to answer a 10-question true-false test. How many different ways could you answer it? Well, here's question number 1. You have 2 choices for number 1, right? How many choices do you have for the second question? 2. Aren't all these 2 choices for all these? So what's our answer? 2 to the 10th. Very good, Janae. That's right. It's 2 to the 10th. There are 2 choices for each blank, and there are 10 blanks. So 2 times 2 times 2 times 2 times 2. How many ways can 4 different prizes be given out if there are 10 people in the contest?
10 times 9 times 8 times 7.
Bingo, that's it. 10, 9, 8, 7. She's exactly right. Now, kids, there are 10 people in the room. I am going to give away my marker. How many choices do I have of people to give my marker? 10, right? But now I've given Ruben the marker. Now I'm going to give away my worksheet. How many people are left for me? 9. And then I'm going to give away an eraser. 8, and then I'm going to give away my pen. There it is. Multiply all those together. I don't know what that number is. You have a calculator? It is 5,040. It is not factorial. There is no factorial in there. Factorial is used when you have 10 things and you are arranging all 10. All right, next. How many license plates are possible if they must consist of 2 letters, so these are letters, followed by 3 non-zero digits? So you are going to build a license plate that has 2 letters and then 3 numbers that aren't zero, non-zero numbers.
26 times 25 times 9 times
How many choices of letters? 26. Now, whoa. Yeah. Guys, wait a second. Have you ever seen a license plate that had 2 of the same letters?
Yeah.
Yes.
Oh.
Unless the problem tells you you can't repeat, you can't assume you can't repeat. You can have a license plate with 2 A's. So there are also 26 choices for that blank.
What's one?
And then 999. Because normally I would say 10 because there are 10 digits, but you can't have 0 because it says in the problem. It says in the problem no zeros.
Let's go tomorrow.
Now, number 10. How many plates are possible if nothing can repeat? So it's the same kind of license plate, but nothing can repeat. So would you still have 26 here? Yep. Then 25, 9, 8, 7, and all that gets multiplied together. So this is how many with no restrictions.
492.
This is how many if you aren't allowed to repeat. How many 4-letter call signals are possible if every letter is allowed? So, like a call symbol, what they mean is like WTHR. That's a call symbol for channel 13. So they want to know how many 4-letter, they're letters, 4-letter call symbols are possible with no restrictions at all. What would it be? 26 to the 4th. It'd be 26 times 26 times 26 times 26. Very, very good. Now the very next problem says, well, what if you're not allowed to repeat? Well, that would be 26, 25, 24, 23, all times together. So this is number 11. This is with no restrictions. This is number 12, where nothing can repeat. Now look at number 13. No vowels. So we're going to do the same thing. We're going to build a 4-letter combination here,
Sometimes what you consider
but
Y?
no
Are
vowels.
we counting Y? Are we counting Y?
So there are 5 legit vowels. So there's 21.
I don't know, man. There's sometimes Y.
Now the problem does not say I can't repeat. It says go back to number 11 and just exclude the vowels. So that would be 21, 21, 21. Number 14. Now, no vowels and no repeats.
21,
21, 20, 19, 18, all times together. That is no vowels and no repeats.
Are you going to be finding out like an actual number for these?
Yes, but I gave my calculator away to Kevin Cole. I'm pretty sure you know how to type them in on your calculator, so yeah. On a test, we'll want an actual answer right now. The setup is what we're getting at here. All right, here we go. Number 15. Baseball team has 9 starters. How many different batting orders are possible? 9 factorial. So problem number 15, if we wrote it out, would have 9 blanks. Everybody bats. So 9, 8, 7, 6, 5, 4, 3, 2, 1, which is the same as 9 factorial. Hey, guys. Oh, that was what? 15, so now we're on 16. How many are possible if the pitcher has to bat last? Yes, that would be 8 factorial. Here's why. Let me draw it out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here is all 9 guys. Or here are all 9 guys. They are telling you the pitcher is batting last. So you have one choice for the last spot. So Ruben's the pitcher. We know he's the last. Reuben, go stand over there. He's last. How many kids do I have to pick from to that first now? 8. And then it goes down. So do you see how that is going to come out to be 8 factorial? Yeah. Good work. How about if the pitcher bats last and the best hitter bats third? So we have one choice here because there's one best. We have one choice here, pitcher. So now we're going to have what? 7 factorial, yeah? That's exactly right. 7 factorial. Those extra ones stuck in there don't change the answer, right? Right. Now, number 18 it's an easy problem, but it has a new concept in it. So Kia and John, let's pay attention. Number 18 says, I am going to make a 1-digit number, a 1-digit, or a 2-digit number, or a 3-digit number. Out of 1, 2, 3, 4, 5, 6. So my choices are, I can only use 1, 2, 3, 4, 5, and 6. Those are the only numbers I can choose from. So how many numbers are there for me to choose from? 6. So as far as 1-digit numbers go, there are 6. Would you agree with that?
Yeah.
So I'm done with that. There's 6 of them. Now I'm going to make some 2-digit numbers now. If I'm going to make 2-digit numbers, how many choices do I have for this? 6, right? I could start with a 1, a 2, or whatever. So I have 6 choices.
The number of the digits.
How many choices do I have here? 7. I only have 6 numbers to pick from, so there's only 6 right here, right? Now, somebody says, and Mrs. Ford, how can there be 6? Does the number 33 qualify as a 2-digit number that uses only these digits? Yeah. I can repeat digits. So there are 36 of those. There are, if you wrote out all the possibilities, which you would never want to do, but if you did, there'd be 36 of them. Now what about 3-digit numbers? 6 times 6? Which is 16. Right now, wait a second. You figured out that there are 6, Kia, there are 6 1-digit numbers, 36 2-digit numbers, and 216 3-digit numbers. So how many are there all together? Add them up. Bingo. Add them up. In this one problem, there is multiplication and addition. This was all multiply, right?
Yeah.
But we ended up adding up all the options. Here is the key word. When it says you can pick 1-digit or 2-digit or 3-digit, you're going to add. You're going to add those options. The word or always means add up the options. James, you paying any attention? Yes. Okay. The word or tells me I'm going to add. If the word and is in the problem, that always means multiply. So later we'll be doing some probability problems. And when it says what's the probability of pulling a green marble and a blue marble, I will multiply those. But when it says pulling a green or a blue, I will add those. The word and means multiply. The word or means add. Okay, where am I? How many, am I 19? Yeah. How many 5-letter words can be formed from the letters of the word Chevy? What do you think?
4 factorial.
Why 4 factorial?
Need a vowel.
Well, you're allowed to use a vowel. Oh, I see what you're saying. No, the word, the word is in quotation marks. So we just need letter combinations, not legit words. So how many would it be? 5 factorial. There are 5 letters, and you can arrange 5 letters 5 factorial ways. They won't all be real words. They're just letter arrangements. 5 factorial. How about pre-cal? 6 factorial. Pre-cal is 6 factorial. How many social security numbers are possible if all arrangements are possible? So in other words, you're allowed to use any number anywhere. How many social security numbers would be possible? How many numbers are there? 10. 10. 10. Now, I do not know what the real life restrictions on social security numbers are. For example, can a social security number start with a 0? I have no idea.
Maybe.
The problem says, does yours start with a 0?
I think mine does.
Oh. The problem says any arrangement is okay. So we got 10 times 10 times 10 times 10 times 10. Now, what is that when you multiply all that together?
10 to the 10. 1 times 10 to the 10. 10 to the 9. 10 to the 9.
Yeah, what's 10 to the 9?
1 billion.
Isn't that a billion?
1 trillion.
Oh my lord.
I think it's a billion, isn't it? Because you can use 0. 0 is a digit. There are 10 digits. Now, do you see a problem with social security numbers if the maximum number that can be created is a billion? What if there's more people than a billion? What will have to happen?
More numbers.
Either we'll recycle numbers, or we'll create more numbers by tacking on digits.
I have letters.
You do not have letters in your social security number. I guarantee that.
I don't know what I'm thinking about. What am
The
I
answer
thinking
is
about?
all this times each other.
I've never seen
10 times 10 times 10, 9 times, so 10 to the 9.
Do I know? Dude, I swear.
We've been following.
How many telephone numbers, guys, you gotta get through these last couple problems. How many telephone numbers are possible in the 317 area code?
A million.
No. No. Now listen, this is a real life situation that happened recently.
Oh yeah.
There
What
are,
happened to Ruben?
in the 317 area code, assuming any number is usable in any position, there would be just 10 times 10 times 10, and then 10, 10, 10, 10, right?
Why would you put it in the first number?
Okay, assuming any number is doable. So you could have a phone number that was all zeros, for example.
That's sick.
Again, I don't know the rules.
Oh, it's
But the area code is 317.
317's out here.
Oh, never mind. I see the number.
Now,
It'll be 10 million.
we're not leaving until I get through these 2 examples. You want to keep talking, go right ahead. You're just going to be stuck here. Now, here's the problem. That is only, what, 10 million?
Yes.
In the 317 area code. All right, now stop a minute, guys. Back when I grew up, there were 7 people in my family, or 8 people in my family, right? 2 parents and 6 kids. We had one phone. One phone. Had the house phone. That was it. Now, think about an 8-person family now. At a minimum, an 8-person family now is going to have 8 phones. And if they have a house phone, that's 9. And if they have an office phone, that's 10. So what happened recently was we outgrew the possibilities. There weren't enough numbers to go around. So what did they do? They added an area code. They added an area code to Bloomington not long ago, and they added an area code up in Fort Wayne not long ago to accommodate all of these phone numbers, because there aren't any more possibilities. That would be it, maximum. All right, so we're gonna stop there.
So is it?
So the answer is 10 to the 7th. 10 to the 7th. All right, so, yeah, stop the video.